All right, everyone. This is part two on the series of question one for NECO physics practical that involves the period of oscillation of a spiral spring. Okay, here in this video, all I want to do is to manipulate the readings without carrying out the experiment. And if you are looking forward to carrying out this experiment, look down into the comment section. The video on how the experiment was carried out will be posted there. By the end of this video, I'm also going to draw the graph of what we are doing. So I'm going to draw the graph of what we are doing here using these values here. Okay, so without much ado, let us quickly start on how to manipulate this. You have been provided with a retort stand, clamp and bus, a set of masses, a spiral spring, stopwatch, split cork, and other necessary apparatus. Using the diagram above as a guide, carry out the following instructions. So based on the materials they ask to supply. So let's see. Let's read to suspend the spiral spring vertically as shown in the diagram. You can see here. Then suspend a mass hanger on the free end of the spiral spring and add a mass M is equal to 50.0 gram to the hanger. Pull the hanger gently downwards and release to set into vertical oscillation. Determine the time T for 20 complete oscillations. 5. Evaluate the period T of the oscillation. Also evaluate T squared. You can see that here I have some readings here. The readings that I have here is a question that I actually copied from WAEC Physics Past Question 2011. That is May-June 2011. And you can see the graph that is plotted here. The graph is the graph of the values plotted in that same WAEC Past question. So the graph gives the solution to that question. In that question, they were asked to plot the weight. The masses were converted to weight and against extension. Okay, so this is what they did. They plotted the graph of weight against extension, and that is to determine the force constant, that is K, of that spiral spring. So I'm going to use this graph to determine the value of that spiral spring. That's the first part I'm going to do to determine K. Okay, then after that, I will devise another means to determine the value of K, which is going to be more accurate than this, but any range of values between that I'm going to get and this is going to give you the value of K that you're going to use to manipulate this result. Okay. Now let's look at this. Here, the masses were converted to weight using G. Okay, acceleration due to gravity, and they took the value of G to be 10 newtons. They approximated it to be 10 newtons. So here I'm going to do this, and the value I'm going to get for K is going to be based on G being equal to 10 meters per second squared. Okay, so let's get the value of this. So we're going to take points on this. So let me look for a favorite point. Let's say, let me take this point here. So I'm going to trace it down. But I'm going to trace it to the x-axis. It's going to be on this point, on the x-axis, okay? So this is a very beautiful point to use. So to determine this point, I'm going to take the top value here. So look at this. This is 2.0 Newton, and this is 3.0 Newton. So the midpoint here is going to be 2.5, but we can get a value for the scale. So this is our 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it means that each of the points here is 0.1. So if I get to this point, this is 2.5, 2.51, 2.52. So I'm going to get my slope. The slope, which is going to represent the K, is going to be 2.52 divided by, so I'm going to get this point. Just trace this down. This is going to be, okay, this is 20, 21, 22, 23, 24, 25, 25, 26, 27. This is 28. I'm going to convert that to meters by dividing by 100. So I'm going to have 28 divided by 100. So that's going to give me, sorry, 100. That's going to give me 0.28. So it must be in meters. So when I divide this is my result. So this gave me exactly 9.0 Newton per meter, or this can be the unit. You can use this as the unit. You can also use kilogram. The unit can also be kilogram per second. So that is also per second square rather. So that's also a unit. So you see that K is, the value of K has been found. So this value of K is what we are going to be used. Now you see that I did a research and I dig down and I saw a question to determine the value of K. So it means that you are not using the spiral string. The value of K for that spiral string is 9.8. So this is one method that you can use. Now another method that you can use, let me go to delete this graph. I'm going to delete the graph, and I'm going to look for the value of K from here. Okay. So another method you can use to get the value of K is by converting all of this to Newton. Okay, that's going to be a little bit more tedious than this. So what you're going to do is this. I'm going to divide this, all of this. I'm going to divide every of the value here by 1000. So I'm going to divide every of the value here by 1000. What I mean is that I'll divide each and every one of these by 1000 to convert it to what? Kilogram. Then I'm going to multiply it by 9.8 to get the, that's the approximate value of acceleration due to gravity. So I'm going to do 50. So I'll start with 50 divided by 1000. Just press that on my calculator. There's no need for me to write it on the board. I'm going to do 50 divided by 1000. That's 0.05. Then I'm going to multiply that by 9.8. That's going to give me 0.49. 0.49 Newton. Okay. I'm going to do it for all of this. When I divide this by 1000, that's going to give me 0.9. Sorry, that's going to give me 0.1. And when I multiply that by 9.8, that's going to give me 0.98. So I'm going to pause this down and I'm going to do it for all of this. You can check it out how I've done it. So let's next. Okay, so these are my values that I have converted from grams to Newton. So they are now weights in Newton. So the next thing I have to do is to convert this to meters, because they are in cm, by dividing by 1000. Sorry, 100. I have to convert it. So if I divide by 100, it's going to give me 0.065, and this is going to give me 0.11. All the meters. This is going to give me, this one is going to give me 0.15. Okay, and this one is going to give me 0.20, and this is going to give me 0.25. So I've converted it now. So from Hooke's law of elasticity, we know that F is equal to KE. Here, F is at the weight. So just do this. K is equal to F divided by E. So you get that. So we're going to get the various value for K. Get the various values for K and take the average. So now by so doing, so I'm going to look for my K now. I'm going to have K1. It's going to, I don't need to just start writing. It's going to be F, that's this, divided by the corresponding extension. That's 0.49 divided by 0.065. That's going to give me 7.54 to 2 decimal places. So that's 7.54. So I'm going to do that for all of this also. So let me pause this. Okay, so these are my values for K1, K2, K3, K4, K5. I hope you understand how I did this. From the first, I just divided this by this by this. Now, in the whole lesson of this, you are not able to do this in the examination. The whole lesson of this is to derive a K for you. If you are lucky enough to see this video, you know that you have a value for K that you are going to use for your exam. So we're going to have this. I'm going to sum everything together. So let me add everything. So I'm going to have 9.8 plus 9.8 plus 9.8 plus 8.91 plus 8.91 plus 7.54. That's equal to 45.85. 45.85. So I'm going to divide this by, we have to a total number of 1, 2, 3, 4, 5 values. So I'm going to divide it by 5. When I divide this by 5, then you see that I'm going to have 9 point something. Divided by 5, that's going to give me 9.17. Now you can see that from both methods, I got 9 point something here, and also got 9 point something here. So the value of k that you are going to use should range between 9.0 to 10.0. So choose a value from this. So you see that this is a force constant of a known spring. So you're going to choose any value from this to do your manipulation. Now we already know what the values of k is. Now let's go through the question. Then we'll come back and do the manipulation. Okay, so having known the value of k, I'm going to choose the value of k of 9.17. The period of oscillation of a spring is given as T is equal to 2 pi square root of M divided by K. Okay. Okay, so if we square both sides, we will have T squared is equal to 4 pi squared times M all over K. So what I'm going to do here is this. I'm going to substitute the value of K and pi squared into this equation. So I'm going to have T squared is equal to 4 times 3.14 squared, so divided by 9.17. Okay, I'm squaring this times M. So I'm going to work out this 4 times 3.14 squared divided by 9.17. So that's going to give us T squared going to be equal to 4.3. I'm just approximating to 4.3 M. So the next you have to do is this, because you're going to consider the mass hanger that you added to it. So I'm going to be using a mass hanger of mass 10 grams. So if I'm using a mass hanger of 10 grams, then it means that these masses will increase by 10. So for the first one, we're going to have the 50 gram mass becomes 60 grams, and this becomes 80 grams. So I'm going to work on this too, then I'll feed the table to show you. So I'll divide this by 1000. So that's going to give us 0.06 kilogram. Also, I'll divide this by 1000 too. That gives us 0.08 kilogram. So I'm going to work on this. So I'll use these two to work on the formula that we arrived at here. So when I work on that, I'm going to fill this starting from here, then I'll walk down this way. I'll fill the 2 columns, then I'll pause the video and then fill the rest of this. Then we then plot the graph. So let's put the value of M here is 0.06 kilogram. So in the first part, T squared is going to be equal to So we have T squared is going to be equal to 4.3 times 0.06, and that is going to be equal to 0.258. So I'll feed that here. So I'll feed that in here, and that is 0.258. Okay, so to get t here, I'll take the square root of this. On taking the square root of this, I'm going to have 0.508. Then to get t, because I am dividing t by 20 to get big T, therefore I have to multiply this by 20 to get T here. So that's going to give us 10.16. So we'll do the same for this. Now this time around the mass is going to be 0.08. So I'm going to multiply 0.08 by 4.3, and that's going to give me 0.344. Now to obtain this, I'm going to take the square root of this, and the square root of this is going to be 0.587. Now to obtain T, I'm going to multiply 0.587 by 20. So that is going to give me 11.74. Okay, so I'm going to pause the video and fill all other parts so that we don't waste much time on that. So that's the process you are going to use to get T squared and work it backward to get T to fill your composite table. Okay, so this is the composite table. So I've completed that. Then you notice that here I have t squared times 10 raised to the power minus 3 in per second square. So what I want to do is to write this in powers of 10 so that my graph becomes easy for me to plot. So I'll just move this account is 1, 2, 3. So that would be 258 times 10 raised to the power minus 3. So for this is going to be 344, and for this is going to be 430. For this is going to be 516, and for this is going to be 602. Okay, now we can now go ahead and plot the graph of t squared using these values here against these values here. Okay, now let us plot the graph for these values. So, like I said, so here we're going to draw the graph on this graph we have on the board here. Now, my values are for the masses are 50. Remember, we are plotting t squared against m. So you first of all write the title of your graph. It's very important. Here on this graph, you have seen the graph of. If it is not written there, you can just write it there. The graph of. You can even write it inside of this. So this is going to be the graph of t squared in seconds squared against m in grams. Okay. Now we will determine our scales. We will determine our scale by putting these values here. Okay, now our masses are 50, 70, 90, 110, and 130. So if I draw this on this, if I count this, look at this is, so I'm very open. So that if I count, if I start from there, this is 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. It will not get to 130. So you choose a scale that should be favorable to you. So let's see. If I start this at 0, and I say this is 50, this is 100, and this is 150, I think that will be enough. Okay? That will be enough. Or if I go 25, 50, 75, 100, it will not be enough. So it is the value of data that you are given that will determine how you get your x and your vertical and horizontal axis. I just want to try and get my horizontal axis, then I'll come back and see what we do with the vertical axis. So we need to choose a scale for this. So like I said if I go 0, 50, 100, 150, that will be okay. Now let's see, but it makes the graph to look what? Very small. So what if we go with 20, 20, 40, that will be 60, 80, 100, 120, 140, 160. So you see that will be enough. Okay. Now let's go to the vertical axis. Now, since we have converted the values from powers from the ordinary numbers to powers of 10, the least value is 250. So I'll take that to 200, and the highest value is 602. I can take that to 650 or what? 700. So what if we go this way? We'll start from here and we'll go 100, 200, 300, 400, 500, 600, 700. Okay, that's enough. But you know, we have to allow the graph to be very big. So I'll move this to 800. I can move it to 800 or even to what? 900. That fits in within the data we have to use. So I'm going to start from here, draw my X in my horizontal axis with my ruler. Okay. So we are starting both axes from the origin. Okay. So I'm drawing my vertical axis. Okay, so this is 0. So let's fit in our values. So this is 100. This is 200, 300, 400, 500, 600, 700, 800. So my values end at 800. I want to extend the graph up so that it becomes what? Very big. So here we agree that we're going to use 20, 40, 60, 80, 100, 120, 140. Now, so this is M in grams, and this is T squared times 10 raised to the power minus 3 seconds. Now, because my values were raised to the power of 10, because they were raised to the power of 10, okay, so I must include it on the graph. So it's T squared times 10 raised to the power what? Minus 3. So all these values are multiplied by 10 raised to the power what? Minus 3. Okay, now let's write our scale. I'm going to write my scale inside of this place. So I'll write on the T square axis. So some people, they make a mistake and write Y axis. You are not putting Y here, you are putting T square. So you write T square axis, or you write the vertical axis. T square axis, my scale is, now this is 2 cm. When you count this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 of it is 2 cm. So that's 2 cm. And you see that the gap between this and this, the numerical value is 100. So it's 100, 2 cm to 100. Now don't forget that there is times 10 raised to the power minus 3 here. So you put it times 10 raised to the power minus 3 second squared. Okay? Then for this, it's straightforward. 2 cm. 2 cm again for what? 20 what? Gram. Not unit. Do not use unit. Because the value that you are plotting here M has a unit, which is what? In grams. So this is 2 cm. So on the M axis, if I write M axis or horizontal what? Axis.
2 cm to 20 what? Grams. Okay, now if you have done that, the next thing you have to do is to determine the value for each of the line. So this is 20, and when you count is 10. So when you divide 20 by 10, you're going to have 2. So it means that each of this line has a numerical value of what? 2. Okay, that's a numerical value of what? 2. Then we'll do same for this. This is 100. 100 divided by, when you count this is 10. 100 divided by 10, that gives you 10. It means that each of these line has a numerical value of what? 10. So the vertical axis is 10, the horizontal axis is 2 for each of the line. By doing this, your graph becomes very what? Simple. So we are plotting 258 against 50 grams. 258 here against 50. So let's read. So let's read 50 from here. This is 40. 50 will be exactly halfway between the two of them. So just move this up and let's read 258 from here. So this is 200. Each of this line is 10. So this is 210, 220, 230, 240, 250. This is 260. So 250 is between 258 is between 250 and what? 260. So we just use our discretion to look for a point here. So these are the 260. Okay, let me go again. This is 200, 210, 220, 230, 240, 250, 260. So I'll bring it back then. Now we are plotting against 50. So I'm going to count this with 50. 1, 2, 3, 4, 5. That's 50. Midway between 40 and what? 60. So I'll put a dot here. Now I'm not putting on top of 60 exact, 260 exactly. I'll use my discretion to put it a point between 260 and what? 250. So I'll put a dot and I'll circle it. Okay. To put a dot and a circle is the best method that you use because it gives you opportunity to draw the line of best on the circle. Now the next one is 70 for 334. Now 334 for 70. So 70 should be the midpoint between 60 and 80. But let us read 344 from this. So let's go. So this is 300. This is 310, 320, 330, 340. So get 344 from this discussion and put it between 340 and 350. Okay, so this is 340, and we're going to 70. So I'm going to put it on the midpoint. The midpoint is just 5.4. Let's go. 1, 2, 3, 4, 5. And I'll push it up a bit. Put it up and circle it. Okay. Next, we are plotting 430 for 90. So 90 is going to be between 80 and 100. But let's first of all get 430. So let's go up. So this is 80. This is 400. You can see it down to this side. You can see it. 400. So we are at 80. You see, I'm using this line so that it will be easy for me. If I don't have that, I'll use my rulers to what? Count the line. So this is 400, 410, 420, 430, and we are going to what? 90. So let's go. Midpoint of 80 and 1. So I count 5. 1, 2, 3, 4, 5. So I'll put a dot here and draw another one. Circle. Okay. Next, it is 516 for 110. 516 for 110. So let's do that. 516 for 110. 516 is, that's 516. So let's go for 110. So 110 is between 100 and 120. You can see between 100 and 120. So let's go up to 500. This is 510. 516 is between 510 and 520. So let's our discussion. We'll move it to 110. So the midpoint you can. 1, 2, 3, 4, 5. That's the midpoint. We use our discretion to put it somewhere in between. So put a dot and draw a circle again. And finally, 602. 602, we can't get 602 from here. It's going to be very close. So we just put it on 600. And we're plotting against 130. So we go to 130. Okay, so let's go to 130. So 130 is the midpoint. So let's go to 600. This is 600 at 130. This is 120 midpoint. So this is 120. And you see that we count the midpoint. 1, 2, 3, 4, 5. We just put our dot here and draw this. So this is my point. Now, if you look at this, you see that they form a very straight line. Why? Because I manipulated my what? Result. Because of the fact that I manipulated my result, my lines are going to be what? Very straight. And I'm most likely going to get my best of line of fit from the what? Origin. Let's see if we can get that. So let's get the line of best fit. Here, all the lines will fall into this. They will fall into the line. All these circles will fall into the line because there will not be values up and down. There are little what? Errors. And the errors are due to approximation of errors only. So let's see. So this is how I want to draw mine through the center. So I'm drawing it through this from the origin. But remember, you are not drawing from the origin. You always take your line of entry. But like I explained earlier, I said that because my results are very, very accurate, I can draw it through the line of what best, the line of best through the origin, through the what circle. So let me draw. So we draw this. Okay. Okay. So this is my line of best fit. Okay. So this is my line of best fit. So the next thing I have to do is to determine the slope. Take any point on this, okay? Take any point. This can also be extended upward if you want to. You can extend it upward using a ruler to any length that you want to. So to take your line of best, you need, for me to take, I like taking my line of best fit from a very good point like this. So let me draw this. Use a ruler to trace it down. I'll just trace it to the x-axis. So I won't need to trace it to the other side again. So my origin will not be what? Whatever it is here, 0, 0. So I'll trace it to the x-axis since this actually touches the what? The x-axis. But if it doesn't touch the x-axis, you can draw the triangle. Okay, let me draw the triangle through this point. Let's say this point. So I'm going to draw it through this point. Okay. My right angle triangle is drawn through this point to this point. So my slope, so let me get my slope. So my slope is going to be change in t squared over change in m. Change in t squared over change in m. So that's going to be equal to, then you're going to read off this value here. Now remember that if you trace this way, this is 600, 610, 620, 630, 640, 650 at this point here. 650, this will be 660, so this will be 655. Okay? So I have 655 minus, then come to this place and read this up. But this is exactly what? 100. I'm going to put it into bracket because don't forget that we have times 10 raised to the power what? Minus 3. So you include the times 10 raised to the power minus 3. I'll put the unit also. The unit is what? Second what? Squared. Second squared divided by. So I'll now read this value downward. This one. This is 140, right? Sorry, 140. That's 140 minus this point here. That is 20. So I'm going to subtract this out. This is going to be equal to, so I'll put the unit of this. The unit of this is gram. Okay? So when I subtract this, I'm going to have 555 times 10 raised to the power minus 3 second squared. Okay? Divided by 140 minus 20, that will give us 120 grams. So let me press this out from my calculator. I'm going to press 555 exponential minus 3, that's raised to the power minus 3, divided by 120. So that gave me my slope s is equal to 4.625 times 10 raised to the power minus 3 seconds per gram. Okay? Now, we are asked to evaluate okay, we are asked to evaluate k equal to 4 pi squared over x. So we're going to do this. K is equal to 4 times, we say we should use 22 over 7. 22 over 7 squared divided by our s is 4.625 times 10 raised to the power minus 3. So our s is second squared rather per gram. So I'll work this out. K is equal to, I'm going to do 4 times, open the bracket, 22 divided by 7, then I'll square it. That's going to give me 39.510 divided by 4.625 times 10 raised to the power minus 3. Okay, so I'll divide this by 4.625 exponential minus 3, and that gave me 8,542.7 grams per second square. So